Good morning. I am Mrs. Rabu Ahmed, your math teacher. Today we are going to talk about the converse of isosceles triangle, which is lesson 5 in unit 4, prep 2 geometry. Let's move to slide number 2. Our theorem today, if we have two angles of triangle are congruent, then the two sides opposite to these two angles are congruent and the triangle is isosceles triangle. As we see in our triangle, if we have two angles are congruent or equal in measure, so we have two sides are equal in length, so the triangle is isosceles triangle. Angle C and B are equal in measure, so AB and AC are equal in length, so ABC is isosceles triangle. If the angles of triangle are congruent, then the triangle is equilateral. That means if all the angles of triangle are equal, the triangle will be equilateral triangle. Also, we have here a remark: the isosceles triangle in which the measure of one angle equals 60 degrees is an equilateral triangle. Let's move to slide number 3. We have here an exercise. Complete the following. Number 1. If two angles in triangle are congruent, then the two sides opposite to these two angles are also congruent, and the triangle is isosceles triangle. Number 2. If the three angles in the triangle are congruent, then the triangle is equilateral. Number 3. In triangle ABC, if the measure of angle A equals 50 and the measure of angle B equals 80, then the triangle is what? To know the type of triangle, we should calculate all the angles of triangle. So we will calculate the measure of angle C, that because the triangle, the sum of angles of triangle 180, so 180 minus sum of 80 and 50, it will be 50. So we have two angles are equal. So the triangle is isosceles triangle. Number 4, if the measure of one angle in the right angle triangle is 45, then the triangle is isosceles triangle. That because we have one angle is 90 and the second one is 45. To calculate the third, 180 minus 90 plus 45, it will be 45. So we have two angles are equal in measure, we have two sides are equal in length, so the triangle is isosceles triangle. Number 5, if the measure of one angle of an isosceles triangle equals 60, then the triangle is equilateral. We have isosceles triangle, one angle is 60, so the second also is 60, the third 180 minus 60 plus 60, so the angles equal, all the angles equal 60, so the triangle is equilateral. Number 6, ABC is a triangle in which AB equal AC and the measure of angle A equals 60. Imagine the triangle. Also, if the perimeter equal 18 centimeter, then the length of BC equals what? As we have a given here, AB equals AC and the measure of angle A equals 60. Since the triangle ABC is equilateral triangle, so the angles all are equal, so the sides also all are equal. So BC equal perimeter over 3 equals 18 over 3 equals 6 centimeter. Let's move to slide number 4. Here we have an exercise. In the opposite figure, ABC is an equilateral triangle. It belongs to AC, D belongs to BC, and the measure of angle DFC equals 30 degrees. Prove that triangle DCF is an isosceles triangle. Look at our figure. As we see, we have an equilateral triangle ABC. So all the angles here are equal. The measure of each one equal 180 divided 3 equals 60 degrees. So we can say that the measure of angle ACB equals 60 degrees. And ACB is exterior angle to triangle AFCD. So the measure of angle DCF equal 180 minus 60 degrees equal 120 degrees. So in triangle FCD, we have the measure of two angles. F equals 30, angle C equal 120, we need to calculate angle D. Angle D equal 180, that because the sum of angles of triangle 180 minus 30 plus 120 equals 30. So we have here two angles are equal, CDF and CFD equals 30 degree. So the two sides also are equal, CF and CD. So the triangle finally is isosceles triangle. Let's move to slide number 5. Also we have here an exercise in the opposite figure. AC intersect BD at the point M. MB and MC are equal, and AD parallel to BC. Prove that MA and equals MD. As we see in our figure, we have two triangles. The first one, triangle MCB, has two sides are equal, MB and MC. So the triangle MCB is isosceles triangle. Look to the figure here. We have two sides are parallel, AD and CB are parallel. So we can say that measure of angle B equal the measure of angle D alternate angle, as we see letter Z. Also angle C equal angle A alternate angle. From 1 and 2, 3, we can say that angle A equals angle D, so the two sides AM equal MD. Let's move to slide number 6. ABC is the triangle in which a measure of angle B equal the measure of angle C. Find the perimeter of the triangle. As we see, we have here the given two angles are equal. That means we have also two sides are equal. AB equal AC. So 2x minus 1 equals x plus 3. Here we have an equation, has two arms or two sides. We will collect all the x in one side and all the integers in the second side. So 2x minus x equals 3 plus 1. So 1x equal 4. To know the length of each side, substitute by the value of x and x plus 3 to x minus 1, 9 minus x. To get the length of each side, it will be 7 and CB will be 5 centimeter. So the perimeter of the triangle ABC equals 7 plus 5 equals 19 centimeter. Let's move to slide number 7. In the opposite figure, ABC is a triangle. BD bisect the angle ABC and ED parallel to BC where A belongs to AB. Prove that the triangle EBD is an isosceles triangle. BD bisect the angle ABC. If we have a bisector to angle, that means we have two parts are equal, two angles are equal, which ABD and CBD. That's number 1. Also we have ED parallel to BC, where E belongs to AB. If we have a parallel, we can search about alternate angle or corresponding or interior angle. Here we have angle EBD equals measure of angle DBC, alternate angles. From 1 and 2, the measure of angle EBD equal the measure of angle EDB. Look at the figure 2 for me. So ED equals AB. So we can say finally triangle EBD is isosceles triangle. Let's move to slide number 8. ABC is the triangle in which E belongs to AB. We have two sides here, parallel ED and AC. The measure of angle BED equals 60 degree, and B bisects angle AED. Prove that the triangle ABC is an equilateral triangle. As we see, we have here a parallel, ED parallel to AC, so we can get two pairs of angles are equal. angle BED equals to angle BAC equal 60 degree. As we see, corresponding angle we have letter here F. E belong to AB, and the measure of angle BED equals 60 degree. So the measure of angle AED equal 180 minus 60 degree equal 120. That because we have here two supplementary angles. Also we have EC bisect the measure of angle DEA. So we can divide 120 in two parts to angle DEC and angle CEA. Each of them equal 60 degree. Let's move to triangle ACE. Angle ACE equal 180 minus 60 plus 60 equal 60 degree. As we see, we have three angles are equal. Each of them, the measure of each of them equal 60 degree. So we can say that triangle AEC is an equilateral triangle. That's all, and thank you for your time.